You probably depend on rechargeable batteries every day to power things like cell phones, laptop computers, and other small electronic devices. When the battery runs down, what do you do? Plug it back in, right? Have you thought about what actually happens when you plug it in? How does it recharge? Batteries provide electrical energy by utilizing a chemical reaction, but eventually it slows down because the reactants become used up. To recharge the battery, you need to reverse the reaction. This requires an input of electrical energy, which is why you have to plug in the battery to recharge it. While it's recharging, the battery acts as an electrolytic cell. In an electrolytic cell, electrical energy is used to initiate an oxidation-reduction reaction that wouldn't spontaneously occur. Electrolytic cells are not only used to recharge batteries, but also to separate pure metals from metallic compounds, to separate other chemical compounds like water, and to electroplate metals. Let's look a little closer at exactly how electrolytic cells work. All electrolytic cells contain three main parts: two solid electrodes, known as the cathode and the anode, and a liquid electrolyte solution. The electrolyte solution conducts electricity because it contains dissolved ions that are free to move around throughout the solution. The cathode and anode in an electrolytic cell are attached to a source of electrical energy, like a battery. In an electrolytic cell, the cathode is always negatively charged, and the anode is positively charged. These two electrodes are made out of materials such as copper, silver, and zinc that participate in the chemical reaction. These are called active electrodes. They can also be made of chemically inert materials like graphite, silicon, or platinum. So now that we know the parts, let's think about how they all work together. What actually goes on in an electrolytic cell? First, the battery provides a source of electrical energy, pushing electrons onto the cathode and making it negatively charged. Electrons are also drawn out of the anode, making it positively charged. Once this happens, an oxidation-reduction reaction is activated. At the anode, an oxidation reaction occurs, releasing electrons that then are attracted to the positively charged anode. Meanwhile, at the cathode, a reduction reaction occurs, which uses up the electrons that are building up on the cathode. The oxidation half of the reaction is X negative yields X plus E negative. The reduction half of the reaction is Y positive plus E negative yields Y. After both of these reactions, the end result is that two ions, represented here by X negative and Y positive, turn into neutral atoms or molecules, X or Y. This is possible because of the electrical energy provided by the battery that moves electrons from the anode to the cathode. Electrolytic cells are used for all kinds of things: electroplating metals, recharging a battery, and separating pure metals from metallic compounds. When electrolytic cells are used to separate chemical compounds, the process is known as electrolysis. The word literally means to use electricity to break something. Electro having to do with electricity, and lysis, to break. A common type of electrolysis involves breaking down water to produce hydrogen and oxygen gas. To better understand what goes on inside an electrolytic cell, let's take a closer look at the electrolysis of water. Electrolysis of water is perhaps the simplest reaction that can occur in an electrolytic cell. You only need two electrodes, which are often made of graphite, and water as the electrolyte. Water is an electrolyte because the water molecules will dissociate into hydrogen, H positive, and hydroxide, OH negative, ions. When the electrodes are connected to a battery, the H positive ions are attracted to the negatively charged cathode, where they undergo a reduction reaction to produce hydrogen gas. Reduction reaction: 2H negative plus 2E negative yields H2. At the same time, oxidation at the anode produces oxygen gas and electrons. Oxidation reaction: 2H2O yields O2 plus 4H negative plus 4E negative. Both of these reactions will go on simultaneously as long as there are electrons being provided by the battery. The overall result is the production of two molecules of hydrogen gas and one molecule of oxygen gas from every two water molecules. 2H2O yields 2H2 plus O2. Electrolytic cells are very similar to another type of electrochemical cell called a voltaic cell. Voltaic cells contain the exact same parts as electrolytic cells, two electrodes, and an electrolyte solution. But the chemical reaction in a voltaic cell is spontaneous, which means it does not require the input of any electricity. Instead, the oxidation reduction that occurs in a voltaic cell converts chemical energy into electrical energy. A series of voltaic cells make up a device that we all use every day in many ways: a battery. Remember that we already talked about how rechargeable batteries are electrolytic cells when they're charging? Well, they are also voltaic cells when they're being used to make electricity. In this case, the same cell can be either voltaic or electrolytic, depending on how it's being used. Electrolytic cells use electrical energy to initiate an oxidation-reduction reaction that would not spontaneously occur otherwise. They always contain two electrodes and an electrolyte solution that conducts electricity because it contains dissolved ions. The cathode is the side of the reduction reaction and is negatively charged. The anode is the side of the oxidation reaction and is positively charged. Electrolytic cells are used to electroplate metals, recharge batteries, and separate compounds like water. The process by which electrolytic cells separate compounds is called electrolysis. Voltaic cells are very similar to electrolytic cells, but they use a spontaneous oxidation-reduction reaction to generate electricity.